This is Tom in 0GSG, and this afternoon I'm going to show you how to build this handy little board. This is a board that will allow you to expand the PowerPole power distribution in your shack. It takes one input and gives you 5 outputs, a fuse for safety, and of course an LED to tell you that things are okay. You can put this board together very easily, and we're going to walk through the steps, and we're actually going to build one from scratch. So let's get started. Okay, let's start off by inventorying the parts that we have. We have one circuit board. Make sure to handle this by the edge. In fact, you may want to give it a wipe down with some isopropyl on both sides before trying to solder on it. We've got 3 resistors. 2 of them are marked red, 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 and those are 2.2K resistors that will go in the R1 and R3 positions on the board. You've got a 3rd resistor that will be marked brown, black, red, and that is a 1K resistor that will go in the R2 position. We have the indicator LED. One side of this LED has a flat, and as we put the board together, I'm going to show you how that works. We've got a fuse holder. We have 12 of the Anderson PowerPole pins. Now, if you've worked with PowerPoles before, you might not have noticed pins that look like these. These are meant to be soldered right into this PC board. So we'll have 12 of those, and again, try to handle those as little as possible so that your body oils don't get on the pins, because it may make them work not quite so good. And then finally, you'll have 6 red and 6 black PowerPole housings. These are just like the 15 and 45 ampere PowerPole housings that you're used to work with. So if you're missing any of these parts, stop. Find the parts, because you can't put this together without the parts. Okay, let's get this board stuffed. Okay, let's get some of these resistors put on the board. So resistor R1 on the schematic is a 2.2K resistor. That's going to be one of these red, red, reds. So we're going to take that and bend the leads, just like that. And then we'll insert it into the R1 position on the board. On the back side of the board, we're going to clench these leads. We're going to take our needle nose and just give it a little tug, just like that, on each of the leads, and that will stop that from falling out of the board. We'll do the same with the remaining 2 resistors. So R2 is a 1K resistor, brown, black, red, and that's going to get bent and inserted into the board in the R2 position. Okay, we're going to solder these. Now, I want to show you that the soldering iron tip should be hot. To solder this board, you really need about 425 degrees. There's a lot of heavy copper on this board. And make sure your tip is clean. You will have a sponge, a wet sponge, or maybe a little brass turnings type thing to turn it in. So we're going to take and solder these one at a time. I'm going to use a little smaller solder, and we're just going to hold that iron on there with both the pad and the part, and you can see that solder will just flow right on there. If you bump it, reheat it. We'll do the next one. Same principle. Heat the pad and the lead, and that solder will flow right in there. notice that all of these solder joints should look smooth. There shouldn't be any roughness. There shouldn't be anything that looks crystalline or anything on the joints. And once these have cooled, we're going to hold this over the trash can and we'll clip the leads. You want to clip the leads close to the board. And just for our demonstration purposes, I'm going to grab these two so they don't go flying. Good idea, and I hope that you're wearing safety glasses and we can simply clip it. And again, over the trash can is a great place to clip the leads. Okay, let's install the indicator LED. Now, the LED has a flat side and a shorter lead. The other side of the LED is round and it has a longer lead. Now, you can, with this particular LED, because the case is kind of translucent, you can feel really rather than see that flat. And on the circuit board, you can see that's the flat, so that's the direction it's got to go. Now, will it not work if you go the other way? Well, the colors of your LED will be backwards because we want it to be green when the power's good from the fuse and red when it's not. And again, on the back side, we'll kind of give these a little gentle pull. And put a little solder on that. Okay, let's do the fuse holder. Now it's going to be a little more tricky, but very doable. It's also going to take more heat because the 4 copper pads that are on the fuse holder actually are also on the back side of the board. So this is a significantly large chunk of copper because you're going to be soldering the front and the back. So to do this guy, we're just going to insert it. And here's the trick. Doesn't matter which way it goes, the part does not have a polarity. We're going to turn it over just like that. Now, what's holding it in is simply the fact that it's sitting upside down on your workspace. So now you can proceed to solder this. It's going to take a little bit more heat off your iron to solder this thing down. A good way to start is just to tack the corners. Tack 2 of the corners. So let's do that. Again, I can tell I'm soldering something that's a bigger chunk of copper here. Okay, there's one of the corners. Uh-oh, it moved. So you know what we got to do. We need to reheat that and hold it very still. Just like so. Now I can do the other corner. And you can see that solder flowing, and it's actually going through that plated hole to the copper that's on the front of the board. Okay, so this is the tricky part of the PowerPoles. We need to make sure that these are in the ARRL and Aries standard form, which means that when we look at a PowerPole from the business end, the contact is on the bottom, the plus is on the left, and the minus is on the right. And that same pattern goes all the way across this board. To install the connector pins into the PowerPoles, just orient them carefully first. So on this connector, you can see that the slit part of the connector is facing down, and you can actually see the little bit of tin inside the connector. These 2 pins are oriented correctly. You can see the little bump is right there, facing up, and then this tab with the letter A on it is also facing up. So to insert these, simply stand it up, drop it in, like that, and then take your needle nose, grasp it, and push it down. Drop it in. Push it down, and you'll notice it makes a nice satisfying click when that goes in all the way. And you'll now see, as you look in the end of that you now have the little bump is sticking up. Repeat this for the remaining 5 PowerPole connectors. Then we're going to be ready for final assembly. Okay, let's get the connectors installed on the board. You'll notice I've kind of laid everything out with the connectors in their proper positions. So this is helpful. It helps to have things kind of lined up so that you don't make mistakes, because once you solder these connectors on the board, they're not going to come off. Now, when you put these in, there's going to be a little force necessary to insert them. So you can see that that's going in to the slots. And if I turn that sideways for you, you can see that we're going to have to press and rock on that, and press and rock and get it as down, as close to that board as you can get, and it won't fall out. There's a little bit of an interference fit between the pins and the board. So once you've got that fit in there, then do the same for the remaining connectors. Okay, we're going to start soldering this. It's very important to remember that you need to heat both the board and the terminal. And this board has heavyweight copper and a heavyweight terminal. So it's going to take a little while for all this to heat up, especially on the first solder joint. You don't need to put a pound of solder into these joints, just enough to get a nice rounded edge on the solder itself. The first couple of these joints are going to take you a while, and then as this board warms up, it's going to go faster and faster and faster. So we're going to work our way around this board. And we'll solder those last 2 spots. Okay, let's hook this thing up and see if it works. So I've got the lead coming here from a pretty heavy-duty power supply. Got a red light. Well, it makes sense. Red light, no fuse. So let's put in, I'm just going to throw a 10 amp fuse into this. When I put that 10 amp fuse in there, you can see that the LED went green, indicating that our power is good and our fuse is good. Now let's abuse it just a little bit. I'm going to put a load on this. I've got a dummy load here on the side, and the dummy load is going to draw probably about 12 amps off that. Okay, so we're pulling about 12, 13 amps off that right now. It looks happy. Let's crank it up to 28. That 10 amp fuse didn't like 28 amps flowing, so you can tell that the fuse part of the circuit works. So with this little strip, you need to put an appropriate fuse in for what your load is going to be. With ATC fuses, you can go up to 40 amps. This power strip can handle up to probably 45 and 50 amps continually These power pole connectors are rated at 45 amps, so your total current probably shouldn't be more than 45 amps because that's all that's coming off here. And just one final note about this. If you're really going to draw a lot of current, make sure you're using heavy wire. This is number 10 stranded house wire going into a 45 pin power pole connector. So it just makes sense to don't use a little bitty thin wire to wire this. You'll be disappointed. So there you go. You've built a very nice little power pole expander board, and hope this video has been helpful to you.